All right. Hi, everyone. My name is Max. My co host for tonight is Polo. You should see him on the screen right now. This webinar is brought to you by SalikSPEAK, the Philippines' first crowdsourcing platform for Filipino research. The team aims to promote the importance of research in the development of our country, to humanize, deconstruct, and demystify the notion of the elusive researcher, as well as to empower aspiring researchers in the Philippines.
Speaking of aspiring researchers, before we begin, we have one research on our platform that needs your support. They're nearing their target goal of prototyping their product, a Filipino made woman centered birthing tool, but they need your help. So I would like to invite Gian from the Rebirth team to explain what this new innovation is all about. So, Gian?
Hello everyone. Ako nga si Gian from Rebirth, and let's talk about our project now. So Rebirth is a reconfigurable birthing tool that is woman-centered. So yung design niya ay nakasentro sa mothers na gagamit nito. It aims to provide a positive birthing experience sa pamamagitan ng pagbigay ng options for the mother kung anong position siya gusto manganak. Bakit namin ginagawa ito? So actually sa birthing tools or birthing beds na makikita natin sa hospital, mayroong mga problems na nakikita ang ibang doctors and health professionals. So una, restricted yung mobility ng mga nanay. So hindi sila comfortable habang nanganganak. At yung mga beds na to ay more designed for the comfort or convenience ng mga doctors and nurses. Pero hindi na fulfill yung comfort ng mother. Also, may mga cultural birthing practices na hindi na-incorporate sa design. Actually, nalaman namin na hindi lahat ng mga nanay around the Philippines ay nanganganak lying down or in a bed. Minsan may mga gusto manganak na nakasquat or may mga practices na hindi nanganganak on a bed itself. So, hindi na-account yun ng mga birthing bed na nakikita natin sa hospital. Pero sabi naman kasi ng WHO, it's important that any particular position is not forced on the woman and that she's encouraged and supported to adopt any position that she finds more comfortable. So between dun sa description ko ng birthing beds kanina at sa recommendation ng WHO, merong parang contradiction at dun pumapasok si Rebirth. Si Rebirth ay may dalawang configuration na pwedeng piliin ng mga nanay to give birth in their preferred positions. So one configuration is better for upright positions, and the other position is better for positions like kneeling or side lying and positions like that. In addition to the options na pwedeng ibigay ng Rebirth to make the birthing experience more positive kasi pumipili yung nanay kung paano siya manganak, pwede siyang gamitin sa maraming scenarios. For example, sa hospital, kasama ng hospital bed, or pwedeng sa mga rural health units, gaya nung nasa right na picture. Bakit kami pumunta sa SalikSPEAK for help? So with the help of your donation, you can, as of now, we have the design, pero we need your help to enable the design and the prototyping of Rebirth so that it could be tested with the mothers that we plan to make it with. Yun lang. Maraming salamat po, and I hope you support Rebirth in SalikSPEAK Philippines.
SalikSPEAK, let me just invite you to another event next week. SalikSPEAK is part of this year's Philippine Startup Week, a 5-day virtual startup event of the year organized by the Departments of Science and Technology, Trade and Industry, and Information and Communications Technology, together with QBO Innovation Hub and their private agencies. So this Monday, that's already next week, on the 23rd of November from 5 p.m. to 6 p.m., we're going to have a discussion on Filipino researchers as the next startup founders in partnership with Upscale Innovation Hub. With founder and COO of Envigor, Dr. Merlinda Palencia, and engineer Edward Apigo from DOST. We recorded a few days ago. It was such a fun, malaman, and very sick kind of discussion that we have there. So go ahead and watch that next week. We designed the program with you in mind, so if you're considering creating a spin-off from your research, the discussion is perfect for you. Register your attendance at https://bit.ly/join PHSW 2020 and join in the discussions on Monday. Polo, your turn.
Okay, so now that we're done with our preliminary announcements, let's move on to today's event. So, just a little background for those of you who are joining us for the first time. SalikSPEAK is one of the programs of SalikSIC that seeks to open conversations about research, especially between Filipino researchers and researchers from abroad. So since this is, well, we want it to be very organic, a conversation, we would like to get your comments and questions throughout the whole program, right? We have set up a Slido page that you can go to. So if you can go to slido.com, that's slido.com, scroll down a bit, and then you should see a box to input the event code. So for this event, you just need to type in hashtag SalikSpeak Chella Joey, no spaces. And the next page is where you can send us all of your questions, your comments, and well, but aside from that, feel free to write down what you're thinking in the comments section of the Facebook Live, and we'll be looking at that too. And we appreciate everyone's comments. So keep them coming throughout. Okay.
All right. We will be reading out your comments, questions, and even shout outs. So if you have there. So if our speakers are your professors, you might as well give a shout out, right? Later during the open discussion. We'd also love to hear what you like most about the talk and how we can apply these concepts in the Philippines. All right. Polo, you may want to introduce our first speaker.
Okay, sure. Without further ado, adieu, bye-bye na pala. Without further ado, today we have guests from Mindanao and from Belgium. So both of these researchers are somewhat connected, but we'll hear about them more. Our first speaker today is Dr. Genevieve Martinez. He is the director of the Office of International Affairs at the Mindanao State University, Iligan Institute of Technology. So shout out sa mga taga MSU dyan.
Yes. All right. Our second speaker is Dr. Chellafe Ensoy-Musoro. She is currently based at the University of Hasselt in Belgium, where she is a postdoctoral fellow at the Center for Statistics and coordinator of the International Course Programs, or ICP, a Master of Statistics. Now, Polo and I have been speaking with these two speakers since 2 days ago. Sobrang approachable nila. They are so fun to talk to. So go ahead with your questions and comments for them. All right. Please welcome Joey and Chella.
Good evening,
Good
Max
evening.
and Polo, and Chella,
Hello.
of course.
Yeah, good evening, everyone. Or
Good
good
evening.
afternoon
Hi.
from Belgium.
Yes.
Hi, Joey and Chella. Nice to see you again. Thank you very much again for joining us tonight. Now, but before we begin, I guess we'd like to start the conversation a little bit with getting to know you a little more about your background in research. Specifically, maybe you can tell us about what made you pursue research in your respective field of study. Like what motivated you, what inspired you, and maybe through that we can inspire our audience to follow research to our research career as well.
Maybe we can start with Joey.
Yeah.
Yeah. Okay. Thank you. I can remember when I was young, I wanted to become a medical doctor, but because of these financial constraints, so I need to work after graduation and then pursue master's in UP Cebu, and then until such time that I got this offer to pursue a master's degree in Belgium. And during that time, I was, the scholarship, the money was quite attractive to me. So I didn't have any second thought about that and then applied for this scholarship. And then that was the start of my research career. Yeah.
All right. Thanks,
Yeah.
Joey.
Yeah.
Sorry, go
Well,
ahead, Chella.
yes, yeah. I'm just answering the question directly. Yeah. For me, it was I love math. So I wanted to pursue a degree in mathematics, but then my parents didn't allow me to go out of our island, so I stayed in Leyte,
Why
and then I
not?
took up statistics. And then from then on, I realized that I prefer statistics compared to the pure mathematics, because statistics you can talk with other people. I found that more interesting, and then to be able to to relay the results, the numbers, make numbers meaningful to other people. And then I also got a scholarship to study here in Belgium. And then that's when I first really met the methods related to spatial analysis, and I saw these beautiful maps, and then I saw the models behind those maps, and then I was like, wow, this is something I want to do, to really use some theoretical things and make it meaningful, or make it clear to others, to non-statisticians. So that's why.
Thank you, Chella. I think we have a very wonderful start there. I mean, if you haven't noticed it yet, this group of people, we like chikahan, right? But before we get carried away, we need to go to serious stuff over for our speakers. Now we give the screen to them. So again, let's all welcome our first speaker, Joey. Joey, go ahead.
Thank you, Max. Okay, I think, Polo, can you see my presentation? Okay. First, I'd like to express my gratitude to the SalikSPEAK team for giving us the opportunity to share our experiences and knowledge. And this is also a good avenue for us to encourage young researchers, young like us, to be optimistic despite the various challenges that we encounter as we embark on our journey. So today we will be talking about biology and statistics. It's a combination of these two disciplines. Okay, so let me start first with a brief introduction of where we come from and what we do. So basically, I'm from the Mindanao State University, Iligan Institute of Technology. So that's in Iligan City, in the northern part of Mindanao. And this is our research building. We call it Premier Research Institute of Science and Mathematics. And we are here on the second floor. So this is our playground. We call this place as our playground because this is where I play with stuff like microscopes with my MSc and PhD students. So I am currently the leader of this research group, the Environmental Nematology Research Group. And just this year, I was appointed as the director of the Office of International Affairs. So you can see the bulk of work, because I was thinking before that I'll just focus on research and teaching. But when the university calls you to serve, then you have to accept it with a happy heart. So I hope that my admin work would not hurt my teaching capabilities and my research activities. So I'm still optimistic, and I think that's just managing my time wisely. So this is my research group. Again, this is composed of MSc and PhD students. So I have here my colleague, Dr. Madamba. She is a microbiologist. And when you say microbiologist, these are people working on bacteria and fungi, because I didn't have any microbiology background in my BSc or bachelor's degree. So I need someone to hop in, a microbiologist in our research group. And yeah, these are my MSc and PhD students. And everyone knows that research needs money, and research without funds is not possible. So personally, I'm just grateful, and probably our speaker as well later, Chella, we are actually grateful to have this kind of opportunity to be with a scholar of Belgium. The arrows here represents the funding opportunities of Vlirus, that's the scholarship arm of the Belgian government. And as you can see, it's quite a lot, and they're quite generous. And so far, I have already taken advantage of the 3 opportunities from my master's to PhD up to now, a project that I'm working on for 2 years. So you can imagine that for the past, since MSc up to this period of time, Belgium has been spending more than 10 million for developing researchers, because they want to develop researchers to go to their home country and make a difference. So that's why they're very supportive to their alumni. And after my PhD, there were some unanswered questions, and then I made a proposal out from that PhD question and submitted that proposal to Belgium. And then we got this South Initiative project for 2 years. And if everything goes well, we can have the opportunity to apply for a bigger project. That's the joint or team project for 4 years. And the amount is now much bigger. So this will now be the collaboration between universities abroad and MSU-IIT and other neighboring universities in the region. And if this team project goes well, we can have the opportunity to apply for this inter-university cooperation for 10 years. And you can imagine the amount of money that will be given to the institute, okay? So it's a kind of a collaboration for 10 years between a university in Belgium and the university in the Philippines. So it's nice to grow with this kind of organization. So you can visit the site, the website, if you're interested. Of course, we have to start from stage 1, that's the master's degree, and then you climb up to this joint team project or inter-university cooperation in the future. So this will be my discussion this evening. I will talk about nematology staying relevant within the Philippine context. Well, nematology, maybe this is the first time that you hear this word. And nematology is not actually new in the Philippines. We have a prolific researcher, a nematologist from the University of the Philippines, Dr. Romulo Davide. He's a very good nematologist. So he started working on nematodes. These are tiny worms. We call this roundworms. Okay, think of an ascaris that can be found in your tummy. They belong to the same phylum, Nematoda. So Dr. Davide worked on plant parasitic nematodes as early as in the 1980s and 1990s, and he made significant contribution to this field. Okay, now, as biologists, we like to use model organisms. We know that we love using these model organisms, but why do we use model organisms? This is because model organisms provide insights that would give us idea of a complex biological process, okay? This stems from the idea that all living organisms share a common ancestor, and that is why the basic traits are universal. They can be found from the simplest cell to the most complicated cell, okay? So if we want to study a phenomenon in complex organisms, it is always good to start with the simple organisms, Okay, the way, for instance, bacteria harness energy is actually similar to the way that humans or complex or higher forms of organisms use energy or harness energy. So these are some of the model organisms that we use. We have Arabidopsis, this is a plant. We have fruit fly, Drosophila melanogaster, C. elegans, the roundworm, zebrafish, the mouse, the earthworm, Eschenia fetida, springtail, and water flea, and the isopods. So again, these are some of the common model organisms that we use to understand complex biological processes. And certainly we use these model organisms as our test species to assess what's happening in the environment, to assess any event in the environment. For instance, if we want to assess soil health, okay, we use these model organisms. When there is pollution, we know that, for instance, this is a forest ecosystem. When there is pollution, these organisms may die, okay? A lot of these organisms may die, okay? And in the aquatic environment, these species may also die during like ocean acidification or oil spill or heavy metal pollution. But the good thing about the environment is that it has the capability, it has the tendency to go back to its original condition or pre-disturbed condition. Okay, so that's quite there. The environment is reversible. So when there is recovery, environments or disturbed environments such as this can go back to its original condition or pre-disturbed condition. Okay, and for us to assess the effect of pollution, and for us to know that there is recovery, we look at model organisms. We look at test species. Okay, now, for us to know that there's pollution and there is a recovery of the environment, we resort to using these different parameters, okay? We can look at the community of, it's a combination of different species in a particular area. We know that this is a negative effect of pollution. If there is this destruction, there is this decrease in the number of species or abundance. Or if you don't want to identify those different species and would just focus on a particular species, you can use population analysis. Okay, if you don't want to identify them, you just focus on a particular species like species A, and then count the number of individuals. You determine the abundance, you determine the population, the number of dead individuals, the number of eggs produced, and their body sizes. So either way, you can use them as your parameters or variables. In ecology or in biology, we call this as the biological response variables, okay? So this is now my model organism, nematodes. So nematodes can be categorized into three. You have the plant-feeding nematodes, that of course they feed on plants. You have the free-living nematodes, they feed on bacteria, fungi, and small invertebrates. And the other group are the parasitic nematodes, so they parasitize humans and insects. Certainly, my specialization would only the free-living nematodes would be the free-living nematodes plus the plant-feeding nematodes. So nematodes are, for us, they are good test organisms because they have this relatively short life cycle. If you pick a nematode from soil and then put them in agar plates, after 3 or 4 days, you will see them reproducing, and you will now have a number of individuals to be subjected or to be used for your experiment. They're easy to maintain. You just have to give them bacteria and they will be happy. Okay, they can survive for several days and reproduce for several days, like 8 to 10 days. They have this transparent body, so that means you can examine their internal organs and you can insert a green fluorescent protein to know if there is this protein expression. Okay. And of course, they perform an important function in the soil ecosystem because since these nematodes feed on bacteria and fungi, and we know that these bacteria and fungi, they're responsible for the decomposition process. So nematodes also promote soil processes such as decomposition and nutrient cycling. So nematode feeding groups can be categorized into 5 different groups. So you have the nematodes that feed on bacteria, nematodes that feed on fungi, plant feeders, nematodes that feed on their fellow nematodes and smaller invertebrates. We call them as the predators, and of course you have the omnivores here. And if you look at the soil ecosystem, you see the plants, they produce certain substances and chemicals, okay? And then these roots, they produce root exudates that are eaten by bacteria and fungi. And then these bacteria and fungi, as mentioned a while ago, they are eaten by nematodes, bacterial and fungal nematodes. And organic matter also is acted by bacteria and fungi. Okay, so you can see in different trophic levels, you can find nematodes. So it's very interesting to use them as model organisms. And the good thing about these nematodes is that we have this general idea that nematodes that are bigger, they have this nice buccal cavity, large buccal cavity. They have this tooth or teeth. They're generally sensitive to soil disturbance. While those nematodes that are relatively small, they're tolerant to pollution. So with this kind of distinction, you can already expect what would happen if the environment becomes polluted or if the environment is disturbed. And we also have this idea that if you have this high ratio of bacterial feeding nematodes over fungal feeders, that indicates rapid nutrient cycling through bacterial decomposition. If you find in the area that you have a lot of fungal feeders, and that indicates that nutrient cycling is relatively slow. Okay? If you have this low population of omnivores and predators, that means there is this excessive input of fertilizers and other forms of disturbances. And of course, if you have this high population of omnivores and predators, then that suggests a healthy soil. So with this kind of information, you will be able to follow our studies, because these are just some of the basic concepts that we need to take into consideration. So we perform pollution impact studies. So we visit like small-scale mining areas, large-scale mining areas. We carry out lab-based experiments. We go to the greenhouse and also perform, of course, experiments, okay? So we go to the field, we perform experiments in the lab. And whenever we do like understanding the effect of heavy metal pollutants, we always follow this approach. We call this the triad approach, where biology works hand in hand with chemistry. Of course, we need to know the amount of chemicals or toxicants that are found in the environment, and how do these chemicals affect the biology or the organism. But this won't be possible without a method or without the bioassay. So this is where your statistics comes in. And it is through this statistics and proper experimental design that would allow us to understand the effect of these chemicals to organisms. Without statistics, without bioassays, I think this is almost impossible to determine. Okay, so we have visited a small-scale mining site in northern Mindanao, and it is actually near a bay called Morcilagos Bay. And this is where people, get their food, fishes, bivalves. So it's an important source of their food and, of course, livelihood. And you can see here that there is an excavated area. This is where people get rocks, boulders of rocks, and then process them in a ball mill. Okay, so these ball mills actually grind these rocks, And then it is also where they used mercury to separate gold from other impurities. And unfortunately, people would just simply dispose of the mercury to the environment, either to the soil or directly to the river system. Okay, so this is S3 here, and you have here the bone meal, which are or that are located in S3, S4, and S5. And S5 is the one near to the bay. Okay, so at least you can follow our sampling sites. And this is about like 1.2 kilometers. So it's S3 is elevated. It's quite high, and then it stretches about 1.2 kilometers going to the bay. Okay, now I mentioned about this diversity indices. These are descriptors that we use. Remember the parameters, the variables that I mentioned a while ago? So these are the parameters that we use in this study. So by just looking at this, you can see that this yellow is actually the reference area, and then you have here the impacted areas, okay? S3, S4, S5. And you have here the abundance of the nematodes, the number of genera, and the different index values. And it's quite clear that in the impacted area, there's this decrease in the number of nematodes, lower abundance compared to the reference site. The reference site is the site that was not impacted. These sites were not impacted by small-scale mining activity. Okay. When it comes to the number of genera, the pattern is there. You can still see that the impacted sites had lower number of genera. Okay. But it's quite surprising that S4 did not follow such trend. I will discuss that one later, what happened here. So basically, impacted sites had lower abundance and lower nematode genera. And we know that, okay, these small-scale mining activities were really impacting the soil communities, the nematode communities. Okay, and then there was this high abundance of sensitive nematode in the most contaminated site, the mercury-contaminated site, S4. Despite the fact that there was a high mercury level, we found sensitive nematode, and we were puzzled. Why did this happen? Why didn't it follow the expectation that we had for impacted areas? Supposedly, there should be a decrease in the abundance and the number of genera, but this did not happen. In fact, the mercury level in S4 was 127 times higher than the allowable limit. It's too high. It's really high compared to the standard level. Okay, so although it did not follow our expectation, but still we published our work in 2018 in a top-tier ecology journal, and we were thankful because it was accepted after a year of rewriting, revising the paper. But nevertheless, we found out several weak points of the paper. We know that one-time sampling is not sufficient. So for us biologists, please bear that in mind, that reviewers are very critical if we only do one-time sampling, especially for ecological studies. And it has something to do with the spatial and temporal variation of the organism. And in this study also, we have this very limited number of replicates, which is actually not good. So if we perform ecological studies, if we can increase the number of replicates, then that would be nice. Okay? So the lesson here is that the proper statistics and sampling techniques should be incorporated in biology. Okay? Because when you perform a study, submit your work to a journal, if they find some flaws in the statistics, fatal flaws, for sure, reviewers would reject your paper. And this is what happened in one of our papers just submitted a few months ago. And then the reviewer said, okay, the weakest point is that, again, it's one-time sampling. We need data for 2019 and 2020 so that you have the biomonitoring, you have data from for 3 years. And that if you have the data for 3 years, that would be nice because you would probably get a good conclusion from your observation. Okay? Again, for biologists, please take note of this one-time sampling. Please, if you can increase, then much better. Okay, going back to this surprising result that we had, this S4 thing. Despite the fact that in this most contaminated site, S4, we still found sensitive genera, and we wanted to know what's happening here. Okay, so this was quite surprising because we know that mercury is really toxic even at low concentrations. They are highly persistent, they enter the food web and bioaccumulate. So in fact, elevated mercury levels were already found in Murciélagos Bay, the bay that I showed you a while ago, and this was caused by the small-scale mining activities in that area, and that was in 2000. So we know that indeed there was high mercury concentration, and mercury concentration should be affecting our nematodes. So our question is, are these mercury concentrations not detrimental to nematodes? So we resorted to performing a lab-based study where we collected non-polluted soil from different sites, from a single site, and then mix them and make a microcosm or microcosms. And then we supplied different concentrations of mercury. Okay, so these concentrations were basically the concentrations we usually found from the field, or we usually found in the field. So we added mercury, and then we collected soils from this non-polluted soil. We collected nematodes at T0, and then we look at the characteristics of these, the soil, by looking at organic matter, nitrogen, phosphorus, clay, and other parameters. And then we incubated the soil for 45 days. And then again, here comes community descriptors, the one that I told you, the biological responses. Okay, so it's just a kind of, usually in ecological studies, we always look at these things. Okay, there are other response variables, but you can certainly use these variables here. So first we have to prove that we are using non-polluted soil. So how do we do that? We have to analyze, we have to check the soil at T0, okay? And we have to make sure that there are no contaminants, there are no pollutants, high level of pollutants. So we need to measure the heavy metals. And we found out that, okay, there were heavy metals, but the heavy metals are within the acceptable limit. So it's fine, it's okay, we're happy. Because if you start with polluted soil, then it would be difficult for you to attribute mercury having the effect, because it would be possible that other heavy metals would be affecting negatively your nematodes, okay? So how will these artificial environment affect the nematode communities? We don't want them to die, because if we take nematodes from the natural environment and put them in glass microcosms, probably they don't like this. So we have to make sure that they are happy in this artificial environment, okay, to proceed with the environment, to proceed with the experiment and to have these viable results. So we look at the community indicators, the abundance, and we look at the community composition, and we found out, okay, even if they are in the artificial environment, there were no negative effects, no pronounced negative effects. So we are okay with this. We are happy. So this simply suggests that the microcosm approach is suitable for this experiment, okay? Because when I checked literatures, I did not really find a method that used glass microcosms or something like this. So it was just our idea. And then, okay, I think we can perform this. And then we'll just have to make sure that they are not negatively affected by this artificial environment. Okay, that's fine. And then we'll look at, again, community descriptors, abundance, the number of genera. And as you can see here, the yellow highlight, you see at 5 and 10 ppm, that's the two highest concentrations, we observed clearly that there was a decrease in the abundance and the number of genera. Okay, so our previous work did not show any negative effect, but our lab-based work showed a pronounced negative effect. So that means to say that there's a kind of discrepancy between the field and lab-based results. And if you look at the genus composition or the identity of the species, the two highest concentrations, they were already different. As you can see, the two circles are separated from the control or the reference treatment and the treatment with 2.5 ppm. And then again, this clearly gives us the idea that nematode community was impacted by mercury at 10 and 5 ppm. So, but this result, we submitted this one a year or 2 years after, and then it got published. And we're happy, very happy. And then, but the moral lesson here is that, you know, there's this discrepancy between field and lab-based results. And what is the implication? We know, we can explain what's the reason, what are the reasons for this discrepancy because of the different factors, pH, organic matter. But what is the implication? The implication is that, you know, in other countries, they have the standard acceptable limits of heavy metals, but in the Philippines, we don't have. This means that we cannot simply borrow values from other countries and then compare to our values because we simply have different soil characteristics. So what we can do, maybe in the future with the help of other soil researchers, the Philippines has to establish their own acceptable limit. And as you can see, you have Australia, Japan, Taiwan, down to China, but you cannot find a standard for the Philippines. Okay? So I talked about this pollution impact, but let's also look at soil recovery studies. We also perform soil recovery studies because we believe that, you know, this environment can actually recuperate, they can recover. So this was our site in the northern part of Mindanao. This was in 1997, and this is a picture in 2019. And if you ask DNR or Mines and Geosciences Bureau, at present, the presence of vegetation is the only criterion for them to judge rehabilitation success. So as long as there are plants growing, as long as there is this green scenery, then they would probably say, okay, the environment is or has recovered. So my question is this area really rehabilitated? This question is very logical because we know that plants can actually persist in high pollution levels. The presence of plant in a particular area does not necessarily mean that the area is healthy because of this fact. Plants can survive at high pollution levels. So I'm proposing, why not look into microbial communities and nematodes? So again, these are the parameters that we use to look at recovery of the environment. And we have here 4 different sites. And then site A was the reference site, and sites B, C, and D, these are our rehabilitated sites. And in this case, we simply compare the descriptors, the nematode community descriptors for 2 years, 2012 data versus 2014, okay, within site. So if you can see that there is an increase in the abundance, then that's a good thing. That means the nematode communities are recovering. If you see that there is an increase in the number of genera after 2 years, that means that's a good thing because there is the reestablishment of nematode communities. Okay, so this simply means that, you know, even if the environment is diminished or is negatively affected, if there is human intervention, or through natural process, these environment can actually recover. And that recovery can be seen by the establishment of nematode communities after 2 years, additional years of rehabilitation. So it's not yet really perfect because the increase was just minimal, but at least we know that there is the reestablishment of nematode communities from this value to a higher value. And we're happy about that. Okay, so the good thing about this data is that we have learned our lesson. So we took data in year 1 and year 2. So we submitted this one. I submitted this one last March. And then I just got the acceptance letter from a journal just yesterday. And it's a very good journal because it has a high impact factor. And we're happy about this progress. I think I'm ready for some questions. And I hope that you understand or appreciate the things that we do in our lab. Thank you.
Wow, I am amazed by everything you shared. So thank you for that. Yeah, everything you said about the nematodes and how they can actually be a better indicator of health rather than what we just see is something very interesting. I found very, it's a lot of food for thought. Because I guess nowadays we base a lot of things on what we see. So
Thank
yeah,
you.
but
Yeah.
so I guess we will save the questions and the comments for later. But for now, we'd like to give a few shout outs to those who are listening to us. Shout out to those students or maybe colleagues of Sir Joey from MSU.
Okay.
Also shout out
Ay,
to
sorry, sige, go lang po.
yeah. So also shout out to those Jodel. He's watching from DepEd Manila, Ignacio Villamor Senior High School. Wow. Senior if you're a senior high school student, I'm really glad that you're here, starting your research career early, maybe?
Okay. Our first shout out actually came from Slido. I think it was adorable. It just says, "Good evening, God bless Sir Joey." It's from Anonymous, but anyway, I mean, it's a good
Daming fans
motivator.
ni Joey.
Oo, ang dami. Sigurado may iba pa dyan, hindi ko lang nakikita. Um,
Yes, and I think we should have
yeah.
more.
Okay, ikaw siguro dyan, Polo. I can't seem to find the shout outs. Sige,
Oh,
go ahead,
okay.
Polo. Weird.
So, yeah, shout out to those watching from Cavite, Makati, and from Antipolo City even. So really, oh, there's even someone from Eastern Samar State University. So that's very nice to
Cool.
hear.
Cool.
So
Vanessa
shout out to all of
Calancing.
you guys.
Yeah,
And
sorry.
I hope you guys continue sharing the stream so that we can get more people into our conversation. And just a reminder for everyone that we have a Slido link that you can go to ask your questions. So we have a few questions already. That's slido.com. And then all you have to do when you go to that site, you scroll down a bit and you should see a box to input the event code. Our event code for today is hashtag SalikSPEAK Chella Joey. Okay. So just type that in and then send in your questions. You can send them as anonymous. We can give your names too. Um, yeah. So before I forget, right? Aside from giving us your questions and comments, if you have a spur of the moment idea of a good speaker that we can have on SalikSPEAK, feel free to send us a message or write in the comment box anyone you would like to have on our show.
Right.
Right? But now we move on to our second presenter for tonight, all the way from Belgium. So
Yeah.
let's welcome to the screen Miss Chella. Chella, sorry. Chella
Hi, Chella.
from.
Hello, everyone.
Chella.
Yeah, Chella. Good afternoon from Belgium.
All right, so Chella, you can Take it away.
Okay, yeah. So, yeah, I am honored to be one of the guests for this November version of SalikSPEAK. Today, I am going to talk about spatio-temporal models, so a little bit different from what Joey talked about, but I assure you that it's connected in some way. And for this talk, I will first start with a brief introduction of the topic. And then I will go into a case study on the spatio-temporal dynamic model for a cattle disease. We call that blue tongue. And I will then look into other examples on the use of space-time models, and then some general discussion and conclusion. And then I will talk a bit on about my research journey. So it's a bit slightly a different ordering than the normal. But if there's enough time, I will also talk a bit on the ICP Master of Statistics and Data Science here at the University of Hasselt, or Hasselt University, and also about our institute, the Center for Statistics. Okay, so as mentioned by Joey on his presentation, one of the issues they encountered in their lessons learned for them in their study is that they did not have enough data. So that's actually one of the issues faced by the scientists when they don't have enough data, or the number of samples they took is not enough, so there's not enough replication, or the measurements needed to be done repeatedly or in various locations. So that's the temporal and spatial component. And why is that important? This is because variability plays an important component in statistical inference. So there is information in variability. And we use this variability or this variance to say something about what we are interested in. Now, because there are various sources of variability, take for example in the study of Joey, they are interested in the soil contamination in mining site. The contaminants or the nematodes that are present would depend on several factors, and most of these factors are beyond their control. That is why, for instance, the second part of his talk in the second study, they did a sort of controlled experiment. So they want to control the what they allow to vary, so that they are able to isolate what they were interested in. And to do this, you need to use the correct or the proper experimental design. And so for instance, if I have this example, this is not mining. So controlling for everything is not always possible, and for some people, you then try to correct it in the analysis. So they already did a study, they already collected the data, and then they realize, oh, there are some things that we should have controlled, but we did not control, and then they try to correct this in the analysis. However, no method or analysis can correct for badly collected data. So you need to properly design your study first. Think about your study, consult statistician before you start it, because you don't want to be sorry in the end and you realize that we should have done something different. So for instance, take this map. This is one of the project that I was involved in, and the researchers here were interested in looking at the prevalence of nodding syndrome. So nodding syndrome is a type of another name for that is river blindness. So they want to look at the prevalence of that and also of epilepsy among a certain population. This is located somewhere in Africa. What the researchers did was to take a sample or to test residents, indicated here in the blue triangle, among residents living within a certain distance from the river. So the green there is the river. So they just took some samples within different communities. Now, why did they do that? It's because this disease is caused, this nodding syndrome disease is caused by a parasitic worm, a nematode, which is carried by a black fly. And this black fly survives near water source. So of course, it's logical for them to take a sample near the river. So a slow flowing river or a fast flowing river. Now, if the researchers, after taking the sample, if the researchers would then want to say something about the prevalence far from the water source, so for instance, in this area, so far from the green line, they wouldn't be able to do it based on the data they have because they only took samples close to the river. Then the data they gathered is not enough to answer that question. Now, it's something that they also needed to take into account is that the black fly population fluctuates depending on the season. So you see here that there's the spatial aspect, which they need to take into account, and also the temporal aspect, which they need to take into account. Now, spatio-temporal models arise when data are collected across time as well as space. And yeah, you need to have at least one spatial and one temporal property. If we look back at on the map, if you think about the map on the previous page, that is an example of a spatial data. So they gathered different samples across different locations. Now, if they do repeated sampling, so if they gather again in another time point, then they will have that temporal component of their data, and then they would obtain the spatial temporal data. Now, applications of spatio-temporal analysis include cases in the domains of biology, ecology, meteorology, medicine, transportation science, and forestry. So it's like a really varied domains that this type of analysis touch on. Now, more specifically in many industry and service sectors, such as traffic management, you have agriculture, you have disaster management, you have location planning or location-based services. Now, consequently, the demand for analysis and modeling has increased. Modeling techniques has increased in parallel with the volume of collected data over the past year. So of course, with large amount of data, you need to have the proper methodology to handle this data. One major application, as I've mentioned previously, of the spatio-temporal analysis is in biology, and specifically in public health domain. So we have the infectious and chronic disease modeling. So this is what I mostly worked on, but not just for humans, but also for animals. In terms of public health, tracking the spread of infectious disease will allow us to identify hotspots for infection. It will also help us understand past infection episodes. So what went wrong? What could have been done to lower the spread of the infection? And it will also allow us to predict future trends. So what will happen next? And this type of analysis is not only, as I said, applicable to infectious disease, but also to some chronic diseases like cancer. So looking at the spatial and temporal trend of cancer cases. Now, an important aspect which we shouldn't forget when talking about spatio-temporal modeling or spatio-temporal epidemiology is the incorporation of the underlying biology. Now, that is a really underlying biology of the disease. That is an important component in a spatio-temporal model, which will allow us to better inform the model and provide more accurate results. So as what Joey mentioned previously, when it's really important to look at the small, so the aspect that result to what you see. So what's behind it? So that's something that you need to incorporate in your models. Now, we will revisit some of these concerns near the end of my presentation. So now I will go into something I did during my PhD, and it's on the spatio-temporal dynamic model for the blue tongue BTV8 transmission. We published this in a paper in PLOS ONE a couple of years ago. Now the blue tongue, I'm not so sure if it's also in the Philippines, is a non-contagious insect-transmitted viral disease which affects this domestic and wild ruminants. So it's actually a virus transmitted by some mites. So yeah, when a mite bites an infected carrier, then it can transmit to another carrier. So it's similar to dengue, for instance. Now, sheep are the most seriously affected species by this virus, and this results to high morbidity and mortality for the sheep, while infection of cattle is largely subclinical. In Europe, it is mostly confined. Originally, it's mostly confined in the southern Mediterranean countries, but in 2006, the BTV8, so BTV serotype 8, had become a major disease of importance in Western Europe, Northwestern Europe. So what was significant, what was important about this infection? This serotype affected cattle much more than sheep. So normally BTV affects sheep more than cattle, but this time around cattle was most affected. And these are some of the commonly observed signs of the infection. So it really affected the animals. Now, what did Europe and what did Belgium do when they faced this epidemic? Now, when this virus arrived, and it was also observed in other countries, what Belgium did was to create a 20-kilometer standstill zone around the infected farm. So this is actually what was mandated by EU. Now, implementation of this restriction zone standstill zone was country dependent. So EU just said, okay, a 20-kilometer standstill zone, but there was no other information how to implement it. So what did Belgium do? What they did was they said that, okay, movement within the standstill zone and between neighboring zones were allowed. So only selling outside that zone is not allowed, but within that zone, that is allowed. Now, around 1 month after first infection, Belgium then declared the whole country as BTV8 infected. And what did that imply? All livestock transport within Belgium was free from restrictions again, because for them, the whole country has been infected. So this is how the number of cases look like in Belgium. It started in this area, and then it spread into the other areas of Belgium. So there was really a huge spreading of the infection. And that's how the temporal component looked like. So this is the number of new cases, or number of newly infected farms. So you see here the solid line that there's the first peak and then the second peak. So it actually looks like a bit like the COVID pandemic. And so the dot is the cumulative number of infections. So what did I do to model this? I fitted as an SI model, or what we call a susceptible infected model, wherein I just said, I assumed that when an animal in a farm is infected, then I categorize it as an infected farm. But when there's no infection in that farm, then that's a susceptible farm. So that farm is still susceptible for infection. And I also assume that a farm is infectious until the winter period. Now, I'm not going to present here the model that I used, since I promised everyone that I'm not going to present formula. So I'm just going to present the results. So these are some of the covariates that I used in my model. And this is because we don't have any information on the population of the mites. So we used some data set as a sub to inform our model on where the mites will be, or the temporal distribution the mites. Another aspect of my model is I also incorporated cattle movements in it. So this cattle movement, or this is actually the cattle trade industry. So the trading of cattle within Belgium. I also incorporated, but it's not shown here, the imports. So this is just basically where the cattle is coming from. So mostly around in the lower part of Belgium, and where it's going to. So here in this part. I then converted this into a matrix looking like this, for instance, and this matrix changes over time. Okay, so this is for one timestamp. I think this is I presented here an average. So so basically, if you can do an average, so this gives you an idea of the cattle trading in Belgium, or you can also do a temporal component of the cattle trading. So actually, different matrices per time point. So I incorporated that into a model. I then fitted the model and I did prediction in order to investigate the effect of restriction. So with cattle movement or without cattle movement. So this is first a more of extremes. So no restriction with complete restriction, or what we call in this Corona period a lockdown. And I did a one-step ahead prediction and a long-term prediction. So this is a cumulative and the weekly number of infected farms with and without animal movement, and this is the dashed is without without movements, and the solid is a with movement. And this is more of a deterministic prediction. So you see that there's no uncertainty plotted here. So what I did was then to do some simulation study to see so that I have an idea about the uncertainty. That is important when you do analysis. You need to report the uncertainty. What I did here was I used data until 7 weeks, so until the line here, to inform the model. And then from that time on, I predicted how the rest of the weeks will look like. So in the model, there's no like temporal component. It's just the biological aspect, and also those covariates, which gives us an idea of how the distribution of the mites. And I was actually amazed that it predicted this second bump of the infection, although you see that it did not predict this really high bump, and it is because we use data only until here. So the model is not really informed about this thing. We did not update the model to this increase in the number of infections. So this is the prediction with movement. This is without movement. You see, without movement, the uncertainty is the interval is really close together. It's short. And this is because with movement, you introduce a lot of variability, a lot of different sources of, a lot of uncertainty. While if you say no movement, you then reduce uncertainty, you reduce the variability. This is also how the spatial spread looks like. So I started with that scenario, and then I predicted how it will spread. So you see here, this is with movement. This is without movement. You see here that without movement, the spreading here does not really occur. So that's how one way I investigated the transport. Another way was also to look at the different restriction scenario. So I did a simulation study using the model that I had, and I simulated the effect of possible different types of restrictions. So there's a total ban, so completely no movement, a no ban, so no restriction in the movement or in the trading of livestock or cattle. And there's two different types of restriction. Restriction 1, I call it restriction 1, and the other one I call restriction 2. Now, restriction 1 is that, for instance, as I said before, that if there's an infected animal in a farm, the government is then mandated to set up a standstill zone around that infected farm. So if I go back here, so there's an infected farm here, and there's a 20-kilometer or some kilometers standstill zone around that farm. If there's an infected farm around here also, they then also establish a 20-kilometer standstill zone around that farm. Now, the first type of restriction is that movement or trading from that restriction zone to outside that zone is not allowed. But buying or purchasing or movement from outside that zone to inside that zone is allowed. So that's the first type of restriction. The second type of restriction, and this is what Belgium did, is that they have the standstill zone, and they said that, okay, movement within the standstill zone is allowed. So purchasing, transport of animals within that zone is allowed, and also between neighboring standstill zones. So since these two standstill zones are overlapped each other, so what Belgium decided is that, okay, movement between these two is allowed. It's only the movement from that zone to outside that zone that is not allowed. So what happened then? So this is how how it looked like. So with the first restriction, you see here that at a certain number of kilometers, certain radius of the restriction zone, the final size of the outbreak will imitate that of a total lockdown. While for the second restriction, if you increase the standstill, the restriction zone, it will then imitate a no restriction scenario. What does that mean? Belgium implemented a 150-kilometer standstill zone. So way beyond what I investigated, and that's why they arrive at this total number of the final size of the outbreak. While, for instance, if they have just even just put a 10-kilometer restriction zone using restriction 2, they would have arrived at a lower number of outbreaks. So that's lesson learned, and this information was then communicated, since we did this project together with the animal health authorities of Belgium. So they actually used this information, the model that we used to change their policies, and they are using our model also for future to investigate future epidemics. Okay, so we see here that there's really the importance of the fine tuning the how these lockdowns, how these restriction zones are defined, and one choice can lead to a completely different Okay, so that's it for the blue tongue. I want to then now talk about some of the examples wherein we used this space-time models. I'm not going to talk about these ones in detail. I'm just going to present to you something about the project. So after we did that blue tongue study, we also did looked at a space-time outbreak prediction. It's just because with blue tongue, when it arrived in Belgium or in Europe, they were surprised. They did not expect that to happen. And after that blue tongue infection, another virus again appeared in Belgium, that was the Schmallenberg virus. So, and also affected the livestock industry. Now, what they wanted to do here now is to be able to say or to predict in advance or to give a warning when an outbreak is starting to occur, or when there's an epidemic that is emerging. But then if you don't know the disease, you don't know what data to use for this, because this is now really for forecasting. So what we looked into is using the surveillance data for space-time outbreak prediction. So there are data that different countries are collecting all the time. And for instance, in this case, with the livestock, they collect all the time info on mortality, on abortion of these animals, laboratory testing, etc. So we wanted to use this data in order to develop a warning system, and which we can be for a known or unknown disease. So it's just general. So for this project, we use the monthly number of reported cattle abortion and also laboratory testing, milk production. So because these are the different aspects that are usually affected when there's new epidemic affecting the cattle. We then use this temporal component or also spatial component to inform our model. We then tried to do a more of combining these different sources of data, so cattle abortion, milk production, those things, to develop this warning system. I'm not going to present the results here, but this one was also done with the animal health authorities here in Belgium. So they have actually we gave them the method in the end and the results that they can do for their monitoring. So from this, we develop a system to identify early if there is a something going on in a particular area. So that's the beauty of doing spatio-temporal analysis. You will see really in some scale. So not just, for instance, a whole Belgium, but in which particular place there something is going on or something is happening. Okay. Another study or another project that I was involved in is in the antimicrobial resistance in Europe. This was a project we did for the European Food Safety Authority. And part of this project was to look into patterns of antimicrobial resistance patterns in Europe. So we had various types of data. This is an example of an E. coli data. And you see here, the top part is the isolates, and the bottom part is the number of positives. You see here that some issues already that you can immediately see in the map, that in the beginning we didn't have information in many of the countries. It's only from until at least this period that we have a little bit more information, and again this period. So that's one of the issues with doing some temporal analysis or spatial analysis, especially in fine scale. You don't have information, and that's something you need to then be able to use a method that can take this into account. Okay. Another thing I'm involved in, but we are currently doing is on the COVID-19 modeling. So the Center for Statistics at Hasselt University, together with Kermid and University of Antwerp, and also many national and international collaborators, we are working on the COVID-19 modeling. You can find more information about this on this website. We are doing several projects. These are some of the projects that the Institute is doing. And currently I'm involved in the spatial and spatio-temporal analysis of incidents. Now, I would have wanted to present some results to you, but this is a work in progress. So and yeah, I do not want to be presenting something that in the end might be wrong. So, but it's a quite interesting project and an interesting collaborative project to be involved in. So this is really, this project is not just U-Hasselt that is involved in this project. This is really a collaboration of different institutes, different funding agencies. Some of these projects are not even funded by anyone. It's just the researchers going together and trying to do something. But yeah, this is also doing this COVID-19 modeling or projects is also, it highlights the importance of collaboration. Because this study, for instance, the result from this survey, the large corona study, this is a survey initially we did, I think it was weekly and then twice a week and so on. The result from this study is used to inform other projects. So it really highlights the importance of collaboration. So you cannot work alone. You need to collaborate with others. So what we did for the COVID-19 modeling is that we give the institute give advice on the National Security Council of Belgium and for lockdown and other national measures. Because we did modeling in this, we look at different different scenarios, and yeah, the nice thing here is that our voice was also heard. So they really listened to the experts, the scientists, and yeah, that might not be true everywhere, which is a pity. Our institute also give advice on the federal regional boards, for instance, on hospital strategies, etc. And as I've said earlier, this really highlights the importance of collaboration and also of transparency. Okay, so those were, yeah, it was just quick because I don't want to spend a lot of time there, but those were just some examples on how when we can use space-time models. So some projects on where we use that those methods. So I'm not going to go into some just general discussion, conclusion. Yeah, some thoughts about this. So in the case study, I showed how movement was used to the movement data. So this was the trade data was used to identify hotspots. It also highlights the role of movement in disease spread. It's also true, for instance, in COVID. So in the spatio-temporal analysis for the COVID data that I'm working on, I also looked at the role of movement in the spreading of this infection, and I used the mobile phone data, where we were able to get the mobile phone data from the providers here and incorporate that in a spatio-temporal model. So, but we used a model that is easy to explain. That is, that non-statisticians can see and they will understand what we are doing, and we can also interpret the results, because that is important when you are doing statistics. And I then showed the use of a dynamic spatio-temporal model in understanding and predicting disease spread, and then that you can use surveillance data for outbreak detection. This one, we already know countries are doing this all the time.
Chella, excuse me.
Yeah.
Chella. Hi, sorry, Chella, I had to interrupt because you already reached the 30-minute mark. Perhaps you can already wrap up so we have time for question and answer. Thank you.
Okay, thanks, Matt. Okay, so so this is I mentioned in the introduction the importance of incorporating the underlying biological aspect in the model. So, for instance, if you are modeling the prevalence of malaria or dengue, you need to incorporate information regarding the mosquito population. regarding the mosquito. So the population density, biting rate, etc. And absence of this data would mean you might need to use proxies for this, like location, where water sources, the elevation, precipitation, etc. So many epidemiological studies make use of similar data. So this is really where you need to collaborate. You need to talk with other researchers in order. You cannot just fit a model to or just start doing analysis to a data without understanding the biology behind that. So you need to understand that in order to get some sensible result. Another important thing to remember is also the scale of the analysis. So data on a fine temporal and spatial scale will allow you a more accurate prediction in space and time. Well, aggregated data will result to more rough or general prediction. But then the scale of the analysis will also dictate the kind of method that you will use. So for Joey was showing earlier the more community-based and individual-based model. So those type of models that you will use will be dictated by the type of data that you gather. So you can have a population-based and also individual-based model. And it's also important to remember that you need to account and quantify uncertainty. So you need to quantify properly the uncertainty of your data set. And also the importance of reporting your results. So how you interpret your analysis properly, that non-statisticians can understand it. And then, the importance of collaborating and communicating your result. Spatio-temporal model, then I will just quickly go over my research journey. So what I did during my time, how I came to this topic. So first, I want to introduce myself. I did not do that. That was intentional. So this is me. I'm married. So these are my kids, and this is my husband. So these are my two young kids. I took up Bachelor of Science in Statistics. I did a Master of Science in Statistics with focus on biostatistics and also PhD in statistics. And you see in the topic of my PhD, I was mostly interested in forecasting and prediction models for demography and animal infectious disease. Now, I met Joey in around 2008 when I started my Master of Statistics. We actually started the master program the same time. So this is a picture of Joey and I and our friends. We visited somewhere, some other place. I think this was Austria. And so that's how I got to know Joey. And we got to talk about doing research together. And then a few years ago, or like last year, was it last year or 2 years ago, I contacted him again to look into collaborating. And so now I'm actually collaborating with Joey and talking about submitting projects together. So I mentioned this already in the introduction, so I will not say anything about that anymore. And so my role in Senstat now is that I'm a postdoctoral assistant or a fellow. I teach courses in the master's program. I also do consultancy mostly for European Food Safety Authority, and I'm doing research, and I'm the coordinator of our scholarship program, or a master program in statistics and data science. So that's it about my talk. Thank you for listening, and I hope to get some interesting questions from all of you.
Thank you so much, Chella. And I can assure you there are interesting questions because there is a slew of them ready on Slido. We'll read them out later, and I'm pretty sure you and Joe would be excited to answer them all. And then at this point, we are going to do shout outs for maybe your students or maybe your future students who would want to get the same scholarships you and Joey did. Okay, so how do I read? Oh, there you go. Good evening, everyone, from Rianeth R. Pantorilla. Okay, that's one. Another good evening from Najma LA. Can't we get like interesting shout outs here? Watching from Cavite, Ariana Ishrin. I'm also watching too from Quezon City. Hi. Okay. Chinli Ortega, thank you so much for such informative presentation, Dr. Martinez. I agree too. And Chella's presentation was informative too. Watching from Caraga State University for that's eyes, dams, and okay. I'm gonna go back to Polo. I think he has reminders for our audience.
Okay, just a quick reminder. We announced a while ago that we are going, SalikSPEAK is going to be participating in the Philippine Startup Week next week. We just like to correct the link that we announced a while ago. So the correct link is bit.ly slash attend PHSW20. Okay, so that's attend PHSW20. So yeah, join us on Monday, 5 to 6 p.m. We'd
Right.
like to see you there.
Okay. Thank you, Polo. Now we go to the questions. There's a lot of them. And the first question that Polo and I chose is something both Chella and Joey can answer. I'm looking at Chella because I know she has slides prepared for this. Okay. For such scholarships from Belgium, where there's so much funding, according to the presentation of Joey earlier, what's the catch? Ano ang kapalit? Is there return service involved? There you go.
Joey or me?
Okay.
Oh, yeah.
Yeah, it's a very good question because when I was starting my scholarship, I also had that question. But the logo of the virus is just go home, just make a difference. Okay, so the catch there is that Belgium government through virus is very supportive to their alumni. Okay, and even after PhD, they're still supporting just to encourage people to go back. Because I have lots of friends, for example, from the US, after finishing their molecular biology, they don't want to go home because they would be frustrated. They don't have equipment. After my PhD, I already had some good microscopes with me from my PhD funding. And with this additional funding for my South Initiative project that allow me to buy more microscopes, not for me, but for my students. So literally, I'm building a laboratory for my students. Yeah.
Right.
And I think if yeah, like Flemish universities, they or Belgian university extend their network, that is also good for their reputation. I've been looking at QS, the world ranking universities, and whenever you have publications together, there are points for that. There is a certain point for that. And exchange professors, there's a point for that. So it's also lifting the reputation of Belgian universities. I think Chella can also add to that.
Yeah. Yeah. I mean, this scholarship, it's really attractive. And yeah, so, but I can't really see any catch in it. So if you think about return service, they encourage everyone to go back to their home country and contribute to use what they learned, but they don't force you. They also give resources or allow you to apply for some resources that you can use afterwards. And like, for instance, what Joey mentioned, he obtained after the master's program, he obtained a PhD scholarship, PhD funding from them, and then a research funding from them. So they encourage their alumni to apply for this funding. And then opportunities later on are they give preference to their alumni. So, and if they, for instance, if they need some collaborator in a specific country, the first person they contact is the alumni. So they don't forget about them. And then they really create opportunities try to create opportunities for the alumnus, for the alumni. So yeah, it's not something that, okay, you study, you finish, and then that's it. Yeah, so it's really, yeah, I mean, I'm not a good example of an alumni because I'm still here.
Why not?
But yeah, but I'm working in the side in Belgium as a coordinator in the ICP program, and this ICP program is funded by Blair. So this is the scholarship program that we obtained. And whenever I go to the first person I contacted to when I was involved in this one is in the Philippines is Joey. And why? Because Joey is an alumnus of the program, and I knew him. And then I contacted again another alumnus to connect. So that's actually the base how we go to if we want collaboration or we want to do something in a particular country, we first contact the alumnus. So that's they really create opportunities for you. So if you can put on my slide, Angelo, what I want to put something. So
We know you're ready.
in the University of Hasselt, we have as of this moment, we have 12 scholarship funding from Blair US to take up this program. And you can take either the trajectory of biostatistics, bioinformatics, or quantitative epidemiology. Application, we are now accepting application. And these are the eligibility criteria. You can check the website for if you need more specific information. So there's not much. You don't need to be doing many things in order to qualify. And for candidates from the Philippines, you don't even need to take TOEFL or IELTS. You just need to have a certificate from your university that says your education is in English. Oh, that's what I love about this. I didn't have to take that.
Yeah, because they know that Filipinos are good English speakers.
Yeah,
Right.
and then there's the allowance as of this moment. So they have a monthly allowance. Then there are several one-time payments. They assist you in your visa application, in your traveling. They pay your insurance, tuition fee, etc. So it's they are really helpful and generous with their scholarship. So I encourage everyone to look into the website. This is the Blair website. These are the different programs. I don't know if these are still true, all of them, but there are some of the programs that are available aside from the Master of Statistics. Yeah.
All right.
That's very
Thank you,
interesting.
Chella. It is like that's such big amounts, and then the catch is so reasonable.
Yes.
Of course, I was looking at the research thing. Very reasonable. Those are millions. Anyway, follow. Maybe you
Really
can go
good
with the
cause.
next question.
Yeah.
Yeah.
Now, I guess people are wondering, okay, the funds are there, the opportunity is there, but someone asked, how is the academic culture in your respective universities, especially when it comes to pressure to publish and possible competition also for the funding that you talked about?
Yeah, can I answer first? Okay. Yeah, I mean, here they really encourage research, they encourage collaboration, they encourage transparency. So it's not like each for their own. They really, you really, and in order to progress as a researcher, as an academician, you need to collaborate. So the pressure to publish is, yes, it's there, but if you're doing research, you publish your work. But they are not like the ones that you hug the research for yourself. You really need to collaborate. If you will connect to as many individuals as you can, the experts in the field, even the starting experts in the field, and that's really just the formula. And there's no I don't think there's really that much pressure in the academy. I mean, there is that level of pressure, but it's a bit different, for instance, in the Philippines. And first, what I like is professors here are approachable. You don't even have to bow down to them, call them professor, doctor, to talk to their name. And then you just, if you need to talk with someone, you just send an email, and then, can I talk to you about something? And then they're open to that. So I think that's one of the things that we are lacking. We are not in the Philippines, some in the old school anyway. There's that something of that. Okay, I'm a doctor. I'm an important person. You cannot just come here talk to me. You can talk with the others. But here is really like, yeah, they're open, and kind of mentality, it's really, it promotes collaboration. It helps in the research. It opens you to more ideas, so you're not afraid to talk about your ideas, to try out new ideas. Yeah.
All right. Maybe we can hear a Filipino perspective from Joey.
Yeah.
Yeah, because I think Chella, if you compare like in Belgium and in the Philippines, we still lack this research culture. Unlike in the
Oh, yeah.
University of the Philippines, it's really established. You have this publish and perish, because you can
Yes.
find good people in Manila, in Luzon, but we cannot simply employ that one in MSU-IIT, where people don't publish, would be, perish. They would be uh, kicked out from the university, because it's very hard to find good people. Even we are now attracting people, but nevertheless, the administration is very supportive, like giving incentives to uh, uh, researchers who can publish based on impact factors. So the higher the impact factor, the higher the incentive. It's very supportive. But we don't have that really pressure, because we're still building that research culture.
Right.
We're encouraged to publish, nevertheless.
So it's still
Okay.
in the works. So I guess that's one of the roles that SalikSPEAK plays, right? And events like this, where we really try to promote research to other people. And to point out, I was actually amazed that when you were showing slides of MSU, at how your facilities looked.
They
It
were
looked like,
so nice.
yeah, I was like, I want to visit your university just to see
Yeah,
how.
you're welcome anytime. You can come
Prism
here.
building, that was so nice.
Yeah, so I agree. We
Yeah.
really need to promote the research culture more here.
Yes, yes.
Yeah,
Right.
and to encourage junior researchers
Mm,
to do more research.
Yeah.
Yeah. Agree with that. All right. Since we can't just talk about research in the context of the academe, we need to bring in more, how do you call it, stakeholders into the mix, because research cannot just be limited to researchers; they need to be commercialized as well. So I'm trying to segue it to the next question here for both of you again. What has been your experience applying or even commercializing your research, especially when dealing with policymakers?
mm,
Okay, I think I can start with answering the
Okay.
question. Um, well, I'm still on the like in the base, like stage 1 or stage 2 of my research. So just focusing on the basic research. Maybe the application, or maybe the application may come in like 5 to 7 years. So I literally don't have any experience on that.
All right. Thank you.
Yeah, for me, yeah, I also don't have any experience with commercializing my research, because I'm more in the background side. But with respect to dealing with, for instance, policymakers, I'm more in a meeting and then just listening to them. And yeah, yeah, it's a special way of, it's a yeah, to communicate to policymakers. You have to talk differently.
Yeah.
They try
Yeah.
to influence your research, influence your output. And I think that's one of the things that, yeah, those we need to be, to find some point that we say that no, I cannot
Right.
do that. That's not correct. We cannot do it. But yeah, it's difficult. It's big, because some of these, yeah, policymakers this is where our money is coming from for research. And
mm.
yeah, we really need to set our foot down and say no. If what they're saying is not correct. But yeah.
So I
Right.
guess crowdfund na lang, right? Para no, not one
SalikSPEAK.
source.
All right.
Yeah. Well, I guess aside from funding, no, going back to your research. As for Joey, we you showed us a slide a while ago how other countries have standards for like the nematodes or these different mineral contents, right?
Yeah.
So even if one of the questions here is even if we cannot use the standards um, of other countries, like are these standards still relevant to us in some way?
Okay. Good question. Maybe I miss. Maybe I missed this one. You can still use, but it's not really the ideal or the most suitable way of adapting these values. In the absence of any data, I think it's better to use information from other countries, but we have to treat this with, care, caution, and yeah. And then if you do that one, you have to make sure that the soil parameters, the soil characteristics should be more or less similar to that of the Philippines. We cannot simply just grab someone or a country from the Europe and then compare it with our parameters. It's better to use maybe Asian countries, which I presume to have more or less similar soil characteristics. Yeah, you can use, but we have to treat that one with caution. You
I
have to
think
be
I
very
like
careful. Yeah.
Yeah, I have a follow-up question. I just so in your research, because you knew that these standards existed, but then they had a different like context. Were you were you able to reach out to other researchers who already did this research abroad to help you with your research now here in the Philippines?
Yeah. Okay. It's still a plan. I have this close collaboration with people with a German yeah, professor from Germany, and he's really into soil ecotoxicology, like establishing these values. So I think it's good that in the near future I'll work with them, like ask for some tips on how they do it, because we cannot simply use nematodes to establish. You need to use a battery of species, earthworms, nematodes, springtails, to come up with these values. Okay, so it's a lot of work, and yeah, we need to collaborate and work with other specialists in the field.
Mm.
All right. Uh, I think that's a very malaman answer we got there. I think Polo is happy, looks happy there. Anyway, so we had that question specific for Joey, and it's only fair that we have a question specific for Chella. And there's this one question I'm looking at, which is really, really interesting here. Was there ever a vaccine developed against BTV8 during that time? And how long did it take for them to get it to market? Yeah.
Yeah, I think in 2017 they developed a vaccine during that time, but it was not really marketed yet. And it was only in 2018, if I'm not wrong, if I'm not mistaken, that it was really out in the market. So actually, after the initial 2016 epidemic, there was a winter effect, and the epidemic came up again in 2017, which was way, way much worse than 2016. So it's looking like the COVID epidemic here in Belgium, where we really went up there. So it was like that, and then it was in I think it's later in 2017 or early 2018 that they had that vaccine, and so we didn't have that epidemic anymore at that rate anyway.
That's great. That's great to know. And sorry, I didn't quite catch that. Like, how long did it take? Like
Something like 2 to 3 years.
2 to 3 years. Okay.
But there's that not much, if you compare to COVID, there's not much urgency, because yeah, these are cattle. Of course the livelihood are affected, but it's not human.
Yeah.
Okay.
And it's
Like,
not worldwide. That's the difference.
right. Humans still superior to cattle, I guess.
No, but
Okay, I
it's
mean,
also the location, like the spread, how
right.
far.
Mm.
Right, makes sense. I wanted to do a follow-up question. This is coming from me. Like I was looking at the abstracts of your publications at the archive I found at University of Hasselt. Like I understood the spatial part. And can you discuss a little bit for the layperson such as me, the temporal aspect of the model?
Yeah, the temporal aspect is actually more of a, I don't want to say a mathematical term. It's more of using the information in the past to
Okay.
say something about what is happening now. So
Okay.
there's not like usually when you do a temporal component, you put like a linear time effect, a quadratic. There's nothing like that. It's really letting the model decide on how the present will look like by using the information in the past. So that's the
Okay.
temporal aspect in the model.
The closest term I could think about, would you say it's something similar to diachronic study, or that's entirely different?
I don't know what is there. It's
Oh, sorry.
random
I'm sorry.
walk. It's more
Oh,
of a random walk or autoregressive type.
okay. Okay. But thank you for the clarification. Thank you. Naano ako, the mental gymnastics. But again, thank you. Okay. I think there is a question from Easter Summer State University. I think this is for Polo to say.
Yes. Oh, although
Okay.
since Chella brought up the topic of COVID and this modeling of diseases, someone asked, is spatio-temporal modeling being used in the Philippines for COVID-19?
I don't really know. Yeah, because I don't know which type of analysis is being used right now in the Philippines, but probably it is being used because that's an important component in you need to take that into account when you look into this type of diseases. So most possibly that is being used.
All right. Thanks, Chela.
Yeah, I guess, well, this next question is pretty deep, but it connects. How important is the temporal aspect of research? Do all research need that aspect?
No, it depends on the type of question and or the topic that you have. So there are some researchers that some topics that the temporal component does not really play a role. But you have to think first on your research question, the type of data that you are gathering, because probably this temporal component will play a role in your outcome of interest. Then you need to take that into account.
And just to
Okay.
add something to that,
Sorry.
because there are some like organisms that they're really happy during wet season. Okay, so we have to take into account the biological aspect. So if those organisms are happy and not happy in dry season, so there's now a temporal variation, and we have to consider that. If we cannot capture that information, then we miss some meaningful knowledge about the study.
Right. Right. Thank you. I mean, it's kind of difficult to do work now without taking into account things that have already been said before. Like, how do you enter a conversation without knowing what has already been said in the conversation? Right. Thank you so much for your answers. We have here from an audience member from Eastern Samar State University. What can you advise to researchers in the rural area like us to come up with such sophisticated and cutting edge research topics without compromising instrumental limitations? That's a handful.
Joey?
Well, it's a difficult question because we can modify. We have tried performing experiments where we modify things, but to the point of modifying things that are no longer acceptable by reviewers. So we get our papers rejected. So from my experience, what I do is I start with the basic ones, experiments that can be done within uh, the the resources that I have. Okay, so take for instance my publication in 2012. It just involved counting of nematodes and stereo microscope, but it got through. It was published in a very good journal. When you start doing these things, okay, start from little things, and then step by step you go to bigger things. You start actually uh, building up your integrity as a researcher. And once you have already this integrity, it would not be difficult to sell your proposal to other funders abroad. Okay? It's just very difficult for me to get funding from the government because it takes time. We cannot do something about that because I think there's a kind of process, a bureaucratic process, and it takes time. It really takes time. So what I can suggest is that I think you try to look for external funders. I think they're quite lenient when it comes to spending money. You can easily buy equipment that you like.
Yeah, I also want to say something about that. I just thought of it. Yeah, when you do research, first, I mentioned it in my presentation, the importance of collaboration. That's
Yeah.
where collaboration plays in. For instance, if you don't have the instrument in your university, another university has that instrument, then collaborate with that other university with your topic. But of course, there's that thing of, yeah, the other university might not know you, or the person there might not know you. And then you need first to build up your name then.
Yes.
So
Yeah.
start, as Joey said, start with what you have and build up your name in that field. You don't, sometimes you don't need funding for those things. Just start to do your own research, or even maybe show some, yeah, some small study that you have done, and then so that you can inform your potential collaborator, okay, this is my initial result, but I need more sophisticated instrument. Then can we collaborate, so that, yeah, I can use your resources, and yeah, those things. So the really importance of collaboration.
Right, right. It's so important. Like, research is one of the most arduous things humans can ever do because data has to be as exacting as possible. So what you want to do is to start with what you have, and then when you think it's already okay or acceptable in the academic community, that's when you start to collaborate. Because I would also say that collaboration is not the easiest job out there because people have different personalities. All right? Divas do not only exist in the arts; they're also here in the academia. Okay, not saying that they're evil. It's just that there's a lot of things you need to deal with. All right. Okay. We've been told that we've already reached the 8 p.m. mark. We've already done 2 hours. But anyway, that is such a wonderful discussion. Thank you so much, Joey and Chella. Since we've heard about what you are currently doing in Mindanao and Belgium, allow us to try and localize our discussion within places here in the Philippines, other than Mindanao, of course. So Polo will start.
I guess uh, Joey and Chella already talked a lot about how um, how research issues are very relevant anywhere in the world, and especially here in the Philippines. It was mentioned a while ago about a bureaucratic process, and I think we see
Oh yeah.
that a lot. Also, when it comes to funding, looking for research funding, not a lot of people recognize that research culture yet, but there's a big yet there, I think, because with the advent, I guess, of social media, especially with the Filipinos very active on social media, you get to come across a lot of many different research innovations or initiatives around the Philippines. And I think what we can do really is to highlight these here in the Philippines, get the message across more, not just to help help build this research culture, but also to um, keep that conversation going and to allow more conversations to happen. Because you never know. One of our research, I think, like Rebirth, just was featured. Rebirth, the project that we featured at the start of this show, was featured online, and things like that can actually gain traction, not just locally but also abroad. Hence, highlighting, I guess, the importance and the value of collaboration. So I guess here in the Philippines, what we can capitalize on is not so much uh, well, it's collaboration between researchers, but also collaboration between research and communication, like the social media, right? Yeah, and hopefully, this culture will be built in a way that even the temporal side of research, given that for a temporal research to be possible, it needs to be very sustainable over a long period of time. And then again, the question of funding comes into play, and you know many other factors. The volatility of support even for a certain project. So yeah, I guess that's all I got, but it's it's something to think about, really. How are we able to promote collaboration whether or not we are researchers ourselves?
All right. I would also like to share what I got from the two wonderful presentations we had is something very personal from me, especially when Joey said something about UP having a culture of publish or perish. I come from UP. I am a faculty member of UP, and Joey said it so succinctly that it hit me. All right, but anyway, I wanted to comment on that because I'm gonna be honest. Naiinggit ako kay Joey tsaka kay Chella because they had wonderful scholarships in Belgium. And the catch is that, they can give back to the community of their choosing. Joey chose to go back to Mindanao. Chella chose to be in Belgium, and it's perfectly okay. And I would like to assume you enjoy your time there. I'd like to assume. I mean, while I was talking to you, you seem like wonderful people enjoying what you have there. It's not always the case with people like me in UP. All right. I was about to comment about the bureaucracy there. I understand that in the academe, our primary goal is to produce new knowledge, hence the importance of publication. All right. But it's one thing to encourage publication, it's another to encourage publication and still treat your researchers as human beings. So what I'm trying to say is that I'm not just talking about UP, I'm talking about a lot more other universities here. You when you give scholarships to these people, I understand that you want them to give back, but you can't force them to go back to a country where the environment does not treat them as human beings. And you two are, I don't know, I think of you as paragons of it. You are researchers, you enjoy what you're doing, and you're widely accepted and encouraged by the universities you're in. And I could only hope all universities, especially here in the Philippines, would have your opportunities and experiences as well. All right. I'll end with that. Okay. Kasi kawawa naman. Gusto na rin naman natin kumain. Okay. I'll end with that. So, again, maraming salamat sa inyong dalawa. I'm gonna give the screen back to Paula. We have a script to follow.
Well,
Paula,
really,
go
just to end, we'd like to ask Joey and Chella to share with us any last thoughts that you'd like to share with our audience tonight. And I think we can end that. And maybe you can also, in your last words, last thoughts, sorry, maybe you can give us maybe your advice to for those students um, who want to come up with a research study, no, and considering um, limits of movement during this pandemic, right? I guess that's another factor, no, that we haven't really looked at. But yeah, maybe you can include some thoughts on that as well in your last comment. Maybe we can start with Joey.
Okay, yeah, it has been a practice in our lab that every Friday we have this free discussion. Okay, it's open to everyone who is interested to join us in our journal clubbing. It's during my free time, I teach them how to analyze the criticize papers, look at methodology. And I think if there are some really interested people uh, to do research, I think we can start with a small group. I can be a tutor for a certain period of time just to give them a push, okay? Because it would be more personalized, and I think the impact would be different rather than just like such as this, like giving a message, a generic message to everyone. So I think you can communicate with me, and then maybe we can decide just a small group. Okay, if you have some questions, then maybe I can entertain them. Yeah, and of course, my piece of advice is just very simple. You just have to be passionate in everything you do. Excel, you have excellence, honor. These are the things. Integrity. These are the important things, especially for us starters. We're building a name here, and yeah, these things really matter. And you have to be fair in all your dealings. Okay, you just be just in all your dealings.
All right.
Yeah.
Chella?
Yeah, okay. From my side, yeah, I mean, doing research is difficult. Getting ideas for research is even more difficult. um, First is, yeah, to start research, you need to get that to be in a proper mindset. I think one avenue that you can have that is, for instance, within your own group, within your own university, to have something similar to what SalikSPEAK is doing. To have this, and you can do this within the even with the lockdown. We are currently doing it now. So by allowing local researchers or your own researchers in your group to present their work, their ideas, and allow others to comment on it, then you can then help build up that research, build up the idea. Because sometimes, yeah, being alone and thinking about a topic, you don't get to you don't go get to anywhere or what you want to achieve. But talking with other people, you then start to get new ideas, and will be able to build up on the idea. And this thing, you don't need to move. You just need your computer or your phone and some internet connection. And I think that's the start of it.
Okay. Thank you, Chel. Napakaganda na sinabi ninyo dalawa ni Joey, and I couldn't agree with you more. Maraming salamat. Polo and I have just last minute plugging to do. We want to thank everyone, the audience members, our speakers, the team behind this talk for joining us in this event, and we hope to see you again in our future events. We also want to thank HEED and Make Sense for partnering with us in this event. Aside from SalikSPEAK, we have SalikSikat, where we invite a Filipino researcher to share notes on our page for a week and have a live session with them by the end of the week. Polo, I think this is your part.
Yeah. So, if you want to be updated, stay updated, and connect with us, just feel free to follow our Facebook page, where you're watching this live feed from. And for more updates, and check out our website, saliksiph.com. And there, actually, you can also pledge your support for Filipino research, or even start your own campaign.
Yes.
So, yeah. Oh, and don't forget, watch our session in this year's Philippine Startup Week on Monday, November 23, from 5 to 6 p.m. You can register your attendance at bit.ly/attend PHSW20. So, yeah, again, thank you everyone so much. Thank you, Chella, Joey, and let's all empower Filipino research together.
Yep. Have a great weekend, everyone. Maraming salamat po.
Bye-bye.
Eating time.